One of the things that people rightly find difficult is Z lines, sort of the M line, the I band and the H band. And the way we need to think about it is you have to learn them and then basically try and imagine how this will look in your mind. So if we take an unlabeled sarcomere, so if we go to this sarcomere down here, we're going to start with the thing that's the easiest to remember, and that is the Z line. So these Z lines are the end of sarcomeres, but don't just say end of sarcomeres in your exam, say the Z line. It actually comes from the word for between in German, which is zwischen. Okay, and what you can do is you can say that these are the ends of each sarcomere. So when you get contraction and the muscle shortens, you should see that the distance between the Z lines becomes smaller. And that's the easiest one to remember. So the Z lines is the end of the sarcomeres, and you'll usually see them shown at the base. The things that become harder is when we start looking at the sort of vague parts which don't have clear sort of distinctions. Any 1 point. So let's start with the I band. So the I band is at the end of each sarcomere where the myosin, where these thick filaments, the thick filament is just another word for basically the myosin, the bit where the myosin heads are mounted, aren't touching the end of the sarcomere. So they're not sort of they've not gone to full contraction yet. So if you come up to our sort of simplified version here, this area here would be the I band. And the classic line they'll ask is what happens to the pattern or the I band in contraction. And what you should hopefully sort of notice is that actually as these sort of areas become more, and so as the sarcomeres sort of shorten and join together, so I'm going to have to do this step by step just to really show you, as this thing contracts, what you should hopefully see is actually that I band which I've just drawn with the dotted lines will get smaller. So bear with me, this isn't exactly how contraction occurs, but that's a decent parameter of it. And we said that the I band was originally where those two black lines were, and now it's shorter. The gap at the end of the sarcomeres, where the myosin filament isn't, has got smaller. So the I band also shrinks. So if we go back, return it to our nice diagram that we had before. So here, what we now have is also the H zone. So if we look at our H zone, okay, so what's the H zone? Okay, so this is the actin filament, So the H zone is the gap between the actin filaments. So if we sort of go through our same process again, let's draw on this diagram in red pen this time. So maybe we got rid of that. Let's go for yellow. So that is our H zone. That's our H zone, and contraction occurs. So let's pull these sarcomeres slightly together because that's how contraction works. So cross-bridge cycling is happening all the time. We'll come to that in a second. And we look now, and we should hopefully see that our H band was originally this long, and let's do this in purple to make it really clear. It is now this long. So our H band has got shorter. The final band that you really get asked about is your A band. And your A band is just the length of your myosin filaments. So the A band, those thick filaments, the filaments, the big old proteins that have all the myosin heads kicking off it, which we're going to talk about in the next video, if you're a little bit confused by that, are these red lines. So if it's basically, they're just the length of the myosin. So if we stretch this back out again and go back to our relaxed state, if we contract this muscle down, so let's put this in purple, if we contract this muscle down, and hopefully you should now see this, your A band actually doesn't get any smaller or bigger because those myosin filaments haven't changed their shape. So that new mark, if we do that in green, that length is actually equal to that length. They're the same. Those red bits have not changed length or shape or size. They're just myosin filaments that will move the actin back and forth over them in what is known as the sliding filament model of muscle contraction. The hard bit is trying to think about what is going on here compared to those little myosin heads, and that's what the next video is going to try and do.